Hey friends, Mrs. Derby here again for lesson 17 this time in Unit 6. This one's going to go hopefully pretty fast. And so we're going to actually have a chance to look at one of the practice problems together as well. Lesson 17 is just comparing transformations. So I want to keep on bringing you back to what we learned in Unit 5 as we're thinking about all of these transformations. Because as I see these examples here on our warm-up, none of them are periodic functions. So they're just bringing us back to the idea about what things would look like. Describe the transformation from the graph on the top to the graph on the bottom. So for each of these, it looks like it's doing a vertical flip. So it's reflecting over the x-axis for every single one of these. It takes that graph and it flips it upside down. So all of these has a vertical flip. We would call that a vertical reflection if we were being super duper mathy about it. But it's okay to just say we have vertical flip over the x-axis for each of these. Now once we flip this one over, it would look like this. And so not only do I need to flip it over, but now I also need to move it 1 unit to the left. And what looks like, let's see, I'm here at 0 at the x-axis. I need to move this down to, looks like -3. So I need to go 3 units down. So we're just being able to do that same kind of description that we did in Unit 5. Okay, so here we have our vertical flip going on. Once I have that vertical flip, this would now look like this. Okay, so flipping over vertically, I have a point here at 2, 2, which would now be at 2, -2. So I'm not doing any kind of stretching or anything to it, just flipping it straight over, and then it looks like I need to slide it down a certain amount. So sliding it from this point here that's on the x-axis is now going to slide down here to -4. Not only is a vertical flip, but now we're going to slide it down 4 units. And last but not least, this one, then if we flipped it vertically, it would, let's see, it would still have the same x-intercepts. That y-intercept would go up to +4. So we would have, with just a vertical flip, we would have something that looks like this. And from there, I need to move that vertex here. So that would mean I would need to move it down 3 units and to the left 1. So a nice refresher about that, just looking at those functions. 17.2 is an info gap. We are skipping that because we are learning virtually here, distance-wise, not virtually. We now have this graph in 17.3. It starts with the cosine graph, so it starts here with f, the blue one. And we need to transform it so it looks like G, the black one. So identify a transformation that takes f to g, and then we have to write an equation for that. And then it says to identify at least one other transformation that takes f to g and write equation for that. So we don't just do this once, we're going to do it twice. But they're going to have the same motions with each other. So let's just start by listing off what the motions are that we're seeing. All right. So let's say we start with a cosine graph. Right now this cosine graph is from -1 to +1. Our new graph, we want to have it go from See, it looks like each line is counting by 1. So we want it to go from 1 to 5. So I see that we're stretching it taller. Okay, so right now it has an amplitude of 1. Remember, amplitude is just from the midline up to the maximum, or from the midline down to the minimum. Okay. So I'm using that word midline. I don't want to spoil something yet. Let me stick here with this idea that it goes from 1 to 5. That means it has a total height of 4 units, going from the midline then up to the maximum would be 2 units. So it has an amplitude of 2. So I'm going to start this cosine graph. I'm going to leave lots of space because I don't know where I'm going to need some information. And with each color that I'm doing on here, something that I'm talking about, I'm going to also put the corresponding change here in the function that would help me show that. Okay? Actually, before we even go any farther, I should have left myself a little bit of room here. All right. So the first thing that we did is we have a vertical stretch twice as tall. The amplitude used to be 1, now the amplitude is 2. It is twice as tall. So here is where we're going to have the change in amplitude. This is our vertical stretch. Not only do we have an amplitude of 2, but I'd like to get back to that idea that we've changed the midline. Right now the midline is at 0. And with our new equation, we've taken that whole midline and we've moved it up a few units. We've taken that midline from 0 and now we've put it up here at 3. To move that midline up, you're seeing me do this here on camera too, that we're just going to take that thing and slide it up. So we want to have a plus 3 at the end. That is our vertical translation. Okay, so we found that guy by what changed the midline. A couple more things for us to think about as we're looking at this graph. I want to think about if it has changed the period. Okay, so our original graph, when I think about the period of it, cosine graph has a period, so it starts here and it doesn't start repeating till here. So it has a period of 2 pi. My new graph, switching to blue here, starts here and that looks like it's right at the midline and it doesn't start repeating again until here. So this one has a period of pi. Okay, so we've changed the period. A great way to think about this is just how many cycles it goes through in a 2 pi span. Okay, so that's how I always think of these two. So I've got this 2 pi section. What was 1 period here, it went through 1 cycle. Now it is going through 2 cycles. So it is half as wide, or we would put that as a 2, because remember everything in the parentheses is going back and forth. So this is like the number of cycles in a 2 pi length. Last but not least, as I was looking at that period, I noticed that this has a different starting point. So notice that this started here up at 1, it has a maximum going on there. When I look at the new graph, the maximum is happening here. So it has shifted horizontally. That maximum that was happening here at 0 has now shifted over and is happening at whatever this line represents. So that starting point, the maximum, it's always good to look for a maximum or an x-intercept or something like that. I like looking for that maximum here. It now happens at pi over 4. So what we did is we took that and we pushed it to the right. And right means we subtracted pi over 4. We know that from Unit 5. Okay? So that is the, let's see, how should we call that? That's, of course, our horizontal translation. And we found that by thinking about where a maximum was happening. We could also think about that starting point of where it was going. Okay, so we pushed that maximum point to the right, we stretched it taller, we slid it up, and then we crunched it together. Lots of things going on here. Now it tells me to identify at least one other transformation that's happening. So, another way that we could go about it, because there's an infinite number of equations we could write that would actually match this, because it's repeating again and again. So I'm going to take a faster way to kind of think about this, right? So here was our new function, and we wrote an entire equation for it. We can also write this in a different kind of way, right? So I'm going to still keep all of that same idea that we have there, 2 cosine, 2 theta, and the plus 3. I'm going to keep all that the same because I haven't changed the vertical stretch. The amplitude is still locked in at 2. Thinking about this still as a cosine graph, we still have 2 cycles and 2 pi, and we have to move that midline up. That hasn't changed. But a different way to think about how we would shift this is that instead of shifting it, taking this graph, this maximum, and shifting it to the right, pi over 4, I could also think about shifting it to the left, right? And if I shifted that maximum to the left, it would move to this point. See how I have another maximum that's about to start heading downward. And I see that that looks like, let's see, 1 pi over 4, 2 pi over 4, a minus 3 pi over 4. Okay, but I'm moving it to the left, and please remember that left means plus 3 pi over 4. So a different way that I could go about it is just to shift it the other direction. There's not much else I could do. I mean, I guess I could technically reflect this over the y or the x-axis. I could flip it upside down, and at that point it would then have this would become a minimum, and then that minimum would have to still shift either to the left, pi over 4, or to the right, 3 pi over 4. So I guess there's another possibility there that we could write an equation for it.